Hello, hello, and welcome to Emergency Physics. Now, I know some people are a little bit worried about a Chapter 5 physics test which is coming up, so a few people have asked me to make this video, so I am complying, and I would like to try to create this and help you out as much as you can. I was sent a homework problem that people were struggling with. Now, right off the top, I'm going to tell you I'm not going to solve it for you, because that would be a really mean thing to do to another physics teacher. Hey, let me solve all your... Because teachers work hard on creating these problems, and I'm not going to do that. I'm not going to give you the answer, but I am going to help you so that you can find the answer yourself. So, you have a roller coaster, your car is 500 kilograms, starts out up here, point H, goes down, whee, it goes out. Now, there's only one place where you really know everything about the roller coaster, and that's at point B. At point B, you know its height, you know its mass. The height is 20 meters, the mass is 500 kilograms, and you know its velocity, 15 meters per second. So that's the only place where you have everything you need to calculate the mechanical advantage. And that is key, because you're trying to find the velocity down at point A. But you're going to need this little bit of information. The law of conservation of energy says that the total mechanical energy is conserved, which means that the mechanical energy at point B is going to equal the mechanical energy at point A. So, that means the mechanical energy is potential energy plus kinetic energy. They're going to be equal, so the potential energy plus kinetic energy at B is going to equal the potential energy at A plus the kinetic energy at A. So let's go ahead and expand them with their more formulas here. I'm just writing this down. So the potential energy is mgh, the height of B, plus 1/2 mv squared. The velocity at B is going to equal mgh, the height of A, plus 1/2 mv squared. And this is the velocity at A. So we have everything we need to do to know to find VA. VA is what we're trying to find, the velocity at point A. So the mass is 500. Gravity, Earthlings, is 9.8. If you're doing this on another planet, consult an almanac to find out the gravitational value on your planet. Almost all of my students are on Earth, at least the ones who are contacting me. All right, so, and then the height, I'm sorry, I'm making a plus sign. That needs to be a times sign. Times the height is 20 meters plus 1/2 mv squared. 1/2, the mass is 500. I know, sorry, my equal signs are drifting because I didn't give myself enough room. Velocity. The velocity is 15 squared. Don't lose that square root. People, you lose a square root and your problems just go crazy, okay? Don't lose the square root. So that's all your values at point B. It's going to be equal to 500. Here's the rag, hold on. 500, that's the mass. Gravity is the same down there, times 9.8 times. Now, here's something nice. You're at ground level. Your height is 0. So that's times 0, which means you can pretty much cancel that out. Forget about it. What's the potential energy of something on the ground? Nothing. Where's it going to fall to? Let's face it. Okay, plus 1/2 times 500 times v squared. Don't lose that squared. That's what you're solving. Now, it's a lot of numbers, but I'll bet you can solve that yourself, because there's only one unknown, and that's VA. You solve for VA, you've got your answer. And I think you can do this. There's nothing here that's extraordinary. Multiplication, you got a square root. Don't lose your squares, don't lose your squares. You can solve that. Now, I know I'm going to get this question. What if I make a mistake? How do I know if I made a mistake? Well, there's one thing you can say for certain. You were going 15 meters per second up here, and then you drop down to point A. So, your speed as you fall is you're not going to slow down. Your speed must be going up. So I can guarantee you, VA is going to be greater than 15 meters per second. I'm not going to solve it for you. I'm not going to tell you what it is, but I got you this far. And I can tell you, if you get a number that's less than 15 meters per second, it's probably not correct. Okay? So I just thought I'd run that by you. Now this was all part A of the question. Part B is almost exactly the same thing. Part B, you're trying to find the velocity. What velocity did it start at? And the same rules apply for part B. So let's just go through them really quickly. Part B, so the mechanical energy at H, point H, is going to equal the mechanical energy at point B. You know what? You've already got that here. Whatever you get for that, just take it in, plug it right in there. Save yourself some time, okay? But again, just so whatever you got there, put it right there. Save yourself some work. You already know this. This is already known to you, okay? But again, it's the potential energy at H plus the kinetic energy at H is going to equal mass mechanical energy at B, which you will have already figured out. Potential energy, it's mgh of H plus 1/2 mv squared at H equals something you've already figured out. Same thing, 500 times 9.8 earthlings times the height is 25 plus 1/2 500 VH is what you're trying to find. Don't forget the square root. And what does that all equal? Well, you've already figured that out. So it's just solving for V. Solving for V again. Now, how do you know if you made a mistake? Well, let's see. You were 20 meters here at 15 meters per second. Here you're up higher, so you're going to have more potential energy. If the potential energy is greater, the kinetic energy is going to have to be less. In order for PE plus KE to be this, in order for the mechanical energy to be the same at every single point, if you've got more potential energy, if you've got more of one form, you're going to have less of another form, okay? So, what can I say for sure? VH is going to be less than 15 meters per second. If you get a VH that's more than 15 meters per second, you've done something wrong. Because it's not like you're going here, and as you go down, I'm slowing. It doesn't happen that way. If you've got, some of your potential will already be in form of kinetic energy. So yeah, you're going to have something slower. You're going to be going slower here than you are lower down the track. So that should be fairly easy, okay? The one final thing I want to help you guys with is the C. Now for C, they basically say, okay, reset, same track, but you don't know that you're going 15 meters per second here. The only thing up here that you know for C is that VH is equal to 5 meters per second. And now they're going to ask you to find VC. So VC equals what? Well, it's the same thing. The mechanical energy at H is going to be the same as the mechanical energy at C. Now, you might have a little trouble figuring out the potential energy at C, but this is 20. So if you're halfway up, this should be 10 meters up. So you have the mass, you know you're on Earth, you're assuming you're on Earth. It's 10 meters up. You have everything you need because you got potential energy here, if you got 5 meters per second, you can figure out the kinetic energy. So kinetic potential plus kinetic, that'll give you mechanical energy. It's going to be the same amount of mechanical energy here. You can figure out the potential. Whatever the difference is the kinetic. And based on that, I think by now, you can figure out what VC is. Now, quick question. How will I know if I'm right? Well, you started out 5 meters per second. So if you're going down here, you're lower down at this point. So I can guarantee you that whatever the speed is, it's going to have to be more than 5 meters per second. If you get something less than 5 meters per second, or you get a negative or something, you've done something wrong. Okay? I don't know what the answer is, but I hope this helps you find it. If you have any more questions, you can look me up. By the way, also I've got other videos. None of the videos are stuff that's in the book, but the numbers on the videos correspond to the chapter and the section in the whole physics book. So if you're having a lot of trouble with, I don't know, chapter 6, section 2, I've got a whole bunch of problems that are chapter 6, section 2. They're not actually in the book, but if you work through them, it'll help you get better at that section and hopefully be better prepared for tests. Okay, thank you. By the way, bye-bye. Well, bye-bye just for a second. I'm actually going to film another video, okay? So there you go.